it so hot?
Not sure.
Oh my gosh, it's so hot. I need to turn on the aircon.
Five hours later.
Oh my god, how did my balance go down to $0 so fast?
Actually, we should have turned on the fan instead.
In this way, it can also reduce climate change and global warming.
Yeah, then you won't be so broke.
In fact, did you know?
According to NTU's 2023 Sustainability Report, electricity usage on campus remains alarmingly high, reflecting the university's expensive operations and infrastructure. Despite significant energy-saving measures, NTU recorded an energy use intensity of 133 kWh per square meter in 2023. While this marks an improvement from the 2011 baseline of 189 kWh per square meter, it underscores the substantial energy demands of the campus. To put this into perspective, NTU saved over 20 million kilowatt-hours of energy in 2023 compared to 2011. However, the current electricity consumption is still equivalent to powering over 4.5k 4-room HDB flats annually, highlighting the scale of the challenge NTU faces in reducing its energy footprint. Moving on, efforts to address this include installing solar panels that generate 11.8 million kilowatt-hours of clean energy annually, enough to power around 2,870 4-room HDB flats each year. NTU has also implemented other systems that save approximately 469,000 kilowatt-hours annually. Additionally, the university has optimized Wi-Fi access points to enhance energy efficiency. These initiatives highlight NTU's commitment to sustainable practices and reducing its environmental impact. However, they also emphasize that significant challenges remain. The university's high electricity usage underscores the necessity for ongoing innovation and collaboration to further reduce energy demands that align with NTU's ambitious sustainability goals.
With that, we have came up with our problem statement, which is how do we reduce aircon usage in NTU halls to save energy? Now, let's look at some of the reasons on why we choose to focus on aircon usage. Aircon is the most energy consuming out of all other electrical appliances such as fans and lights. And it is also cost significant, and the cost is not counted into the monthly hall rent. Lastly, aircon is increasingly deemed as a basic necessity for comfort among people, and hence this is why we choose to focus on aircon usage. Moving on, let's look at some of the statistical terms in this context. With a sample size of 100, a large sample size of greater than 30, by central limit theorem, we can assume that the average hour of aircon usage follows a normal distribution. Also, a condition to satisfy is independently and identically distributed model. In this context, sample points are statistically independent since the hours of aircon usage of a student is independent of another student. Identically distributed requires each sample point to follow distribution of the population and hence will be representative of air-conditioned usage hours.
To analyze the significance of the impact of the different factors on average hours of aircon usage, we will be conducting hypothesis testing, then test our hypothesis in R using linear regression. First, we will define our hypothesis. Our null hypothesis is that the factors, whether it is weather temperature, room type, or habits, do not significantly affect the hours of air conditioning usage in NTU halls. Simply put, this is expressed as beta 1 equals to beta 2, which is equals to beta 3, which is equals to 0, where beta 1, 2, and 3 represent the coefficient for weather temperature, room type, and habit respectively. While our alternative hypothesis is that at least one of the factors, being weather temperature, room type, or habit, significantly affects the air conditioning usage in NTU halls. This can be expressed as beta I does not equals to 0 for at least one I, where beta I refers to beta 1, 2, or 3. Next, we will run a linear regression model to find our p-value. From the linear regression model, we can see that at 95% confidence level, since the p-value is 2.2 times 10 to the power of negative 16, which is less than 0.05, we have strong evidence to reject the null hypothesis. Hence, we can conclude that at least one factor, whether it is weather temperature, room type, or habit, significantly affects the aircon usage hours.
Now let's dive deeper into the significance of each factor in our regression analysis. In our regression analysis, our dependent variable is the number of hours of air conditioner usage per day, and our independent variables are the average weather temperature, the type of room, meaning a single or double room, and lastly, whether the user has a habit of using the air conditioner. Out of these three factors, two of them are statistically significant. The first being the weather temperature, where every 1 unit increase in temperature, the hours of aircon usage increases by around 0.35 hours. Its p-value is less than 0.001, which suggests that there is very strong evidence of its statistical significance. The second significant variable is whether the user has a habit of using the aircon. Those with such a habit use the air conditioner 2.56 hours more than those who didn't. This variable's p-value is also less than 0.001, which suggests that there is very strong evidence of its significance. Lastly is the type of room. For this variable, the p-value is more than 0.05, which suggests that it is not statistically significant. Finally, looking at the adjusted R-square for our model, it has around 84% explanation power for the hours of air conditioner usage per day in NTU halls.
From our analysis, we have come up with two solutions. To address the weather factor, our solution is tinted windows. Since weather temperature significantly impacts aircon usage, tinted windows address the root cause of heat accumulating in rooms due to high weather temperatures. To address the habit factor, we have redesigned the aircon app to include a reward system. Since the habit contributes significantly to aircon usage, our solution involves gamification of the aircon app to raise awareness about energy conservation. Now, I shall not bore you with the details, so let me just try out this updated app for myself. At first glance, this just looks like the regular NTU hall aircon interface. But wait, there's something different here. Oh, I can finally see the number of hours of aircon I use a day. That's a real game changer because it makes me more aware of my aircon usage so I don't use too much. I can't believe I've already used 6 hours of aircon today. All I've been doing is just scrolling TikTok in my bed. Okay, anyways, this looks like the new point system. So every person starts with 100 points, and for every hour of aircon usage, 10 points gets deducted. Let's check out this leaderboard as well. Wait, what? I only have 60 points for the whole week. I better not use my aircon anymore this week. Let's look at what rewards are offered. Oh, there's discounts on hall rental. This is so useful, especially since rental prices keep going up. Okay, I'm definitely going to cut down on my aircon usage to get these rewards. In conclusion, our analysis demonstrates that weather temperature and habitual behavior significantly impacts aircon usage in NTU halls. Using statistical tools such as regression and hypothesis testing, we identified actionable solutions, which are tinted windows and an app reward system. Together, these measures pave the way for a greener, smarter future for NTU Hall.